Hello students, my name is Rishabh Raj and I'm a chemistry faculty at Narayana Educational Institutions. So in this session we are going to discuss about the 21st January Shift 1 chemistry paper. So let's start with the questions. Question number 51. Fructose does not contain an aldehydic group but still reduces tolerance reagent. So there are two statements given. The first statement says that fructose will give tolerance reagent test but it does not contain aldehydic group. So this statement itself is correct. Fructose does not contain an aldehydic group but still it reduces tolerance reagent. Second statement is in the presence of a base, fructose undergoes rearrangement to give glucose. This statement is also correct and that is the reason why fructose, in spite of not having the aldehydic group, will give tolerance reagent test. Let's see how it converts to glucose in presence of basic medium. So if you talk about fructose, fructose is CH2OH, C double bond O, C, OH, H, C, H, OH, C, H, OH and CH2OH. In basic medium, first it tautomerizes. So in basic medium, it will tautomerize. So it will become CH, OH, double bond C, OH, C, OH, H, C, H, OH, C, H, OH and CH2OH. After this, in presence of OH minus, an anion will be formed which will be CHO negative, double bond C, OH, C, OH, H, C, H, OH, C, H, OH and CH2OH. After this it will rearrange and negative will come to carbon. So it will be converted to CH double bond O, single bond C, OH with negative sign, C, H, OH, C, H, OH, C, H, OH and CH2OH. And after that, in presence of a base and water, it will be converted to glucose and mannose. So because of this aldehydic group which is coming on the first carbon, because of this aldehydic group on the first carbon, it is giving us the tolerance test. So in question 1, both statements are correct. So correct answer for this is option number 2. Moving to next question. Question is the element that does not belong to the same period of the remaining elements as per the modern periodic table. The elements given are platinum, osmium, palladium and iridium. So if you see, iron family is Fe, Ru and Os. So osmium is present in this. If you see cobalt family, cobalt, rhodium, iridium. So iridium is present over here. And if you see nickel family, it will be nickel, palladium, platinum. So platinum is over here, palladium is in this. So these three set of elements, they belong to the same period. Palladium does not belong to the same period. So correct answer for this question is palladium. Moving to next question. Question is 2.8 into 10 raised to the power minus 3 mole of CO2 is left after removing 10 to the power 21 molecules from its x milligram sample. The mass of CO2 taken initially is. So let's say we are having x milligram, it means x into 10 to the power minus 3 by 44 moles of CO2 was present initially, and from this we are removing 10 raised to the power 21 divided by 6.02 into 10 raised to the power 23 moles of CO2, and after removal of this they are saying that 2.8 into 10 raised to the power minus 3 moles of CO2 is left. So we have to solve this equation to get the value of x. So we can simplify x into 10 raised to the power minus 3 divided by 44. That will be equal to, we can write it as 0.28 into 10 raised to the power minus 2 plus 1 by 6.02 will be 167 into 10 raised to the power minus 2. So this will become x into 10 to the power minus 3. upon 44 will be equal to 0.447 times 10 raised to the power minus 2. So x will be equal to 0.447 into 10 raised to the power minus 2 upon 10 raised to the power minus 3 into 44. So on solving this, we'll get it as 196.2 milligram. So if we multiply, we'll get, so this will become equal to 0.447 into 10 raised to the power 3 minus 2 is 1 into 44. So this is, we can multiply 4.47 into 44. So that is approximately 196.2. So correct answer for this question is option 2. If you see next question, the question is the major product of the following reaction is. One aldehyde is given and it is treated with excess HCHO and alkali and reflux. So we can see in this aldehyde CH3, CH2, CHO, there is acidic hydrogen. So in presence of a base, it will undergo acid base reaction and there will be formation of enol. So enol will be CH3, CH negative, C double bond OH. And now this enol which is formed, that will attack on one molecule of HCHO. If it is attacking on this molecule of HCHO, okay, let me draw the enol first. Enol will be CH3, CH double bond C, O negative and H, and this enol form now will attack on this carbon. So if it is attacking on this carbon, it will be converted to CH3, CH, CH2, O negative, and this side will have C double bond OH. Now this compound still has one more acidic hydrogen. So again in presence of OH minus, there will be formation of enol. So let me write it as CH3C negative, CH2O negative, C double bond OH, and the enol form of this molecule will look like this: CH3, C, CH2, O negative, and this side we have, let me write it, C double bond C, O negative and H. And after this, enol form of this molecule will attack on another molecule of HCHO. So pi electron will attack on this. So it will be converted to CH3, C, CH2, O negative, CH2, O negative and C double bond OH. Now there is no acidic hydrogen, but HCHO is in excess. So now Cannizzaro reaction will take place. So if I am having HCHO in presence of a base, what will happen? Pi electron will go to oxygen. So it will be converted to HCO negative, OH and H. Then this O minus will come, negative will come back, and this H minus will go out and it will attack on the molecule which was formed in the previous case, that is CH3C, CH2O negative, CH2O negative and CHO double bond OH. So this H minus is going to attack on this carbon and pi electron will go to oxygen. So it will be converted to finally CH3C, CH2O minus, CH2O minus, CH2O minus plus another molecule will be HC double bond OH. And after reflux, it will be converted to option number 3, that is CH3 single bond C, which is attached to 3CH2OH. So correct answer for this question is option 3. Moving to next question. What amount of bromine will be required to convert 2 gram of phenol into 2,4,6 tribromophenol? Okay, so let's write the reaction. We have phenol. It is treated with Br2. So 3 moles of Br2 will be consumed per mole of phenol and it will be converted to 2,4,6 tribromophenol plus 3 HBr. Now 1 mole of phenol will consume 3 moles of Br2. Now they are saying we have 2 gram of phenol. So weight of phenol is given as 2 grams. So moles of phenol we can calculate, it will be 2 upon 94. Molar mass of phenol is 2 upon 94. Now 1 mole of phenol will react with 3 moles of bromine. So 2 by 94 moles of phenol will react with 2 by 94 into 3 moles of bromine. So weight of bromine as per the question will be 2 by 94 into 3 into molar mass of bromine is 160 gram. So it will be approximately 960 upon 94 gram. So 960 upon 94 will be approximately equal to 10.22. So correct answer for this question is 10.22 grams. Moving to next question. The d electronic configuration of an octahedral CO plus 3 complex having a magnetic moment of 3.95 bm is. So we know cobalt configuration is 3d7 4s2. Now they are saying we have cobalt plus 2 ion. So cobalt plus 2 means configuration will be 3d5. Now along with this they have given that magnetic moment of 3.95 bm. This means if magnetic moment is 3.95 bm, this means that there are 3 unpaired electrons. There are 3 unpaired electrons. So if you write the electronic configuration based on Eg and T2G, so the configuration will be 1, 2, 3, 4, 5. Sorry, it is 3d7. So 6 and 7. So in this case, there are 3 unpaired electrons. So electronic configuration for this should be T2G5 Eg2. So correct answer for this question is option number 2. Moving to next question. Propane molecule on chlorination under photochemical condition gives two dichloro products X and Y. So propane will be CH3, CH2, CH3. They are doing dichlorination, Cl2H nu. So dichlorination, so possible products are CH3, CH, Cl, CH2, Cl. Second possible product is CH3, CH, CH3, CH2, CH, Cl and Cl. These are two possible products. One more possible product is CH3, C, Cl, Cl and CH3. Now they are saying amongst X and Y, X is an optically active molecule. So among all these three, optically active is this one. So this is our X. Now they are saying how many trichloro consider only structural isomers will be obtained from X when it is further treated with chlorine under photochemical conditions. So if it is treated with Cl2, so how many trichloro products will be formed? So one possible product is CH2, Cl, CH, Cl, CH2Cl, plus second possible product is CH3, C, Cl, Cl and CH2, Cl, and third possible product is CH3, CH, Cl, C, H, Cl and Cl. So these three are the possible products. So correct answer for this question is option 3, that 3 products will be formed. Moving to next question. Again, two statements are given. First statement says in Lassen's test, the covalent organic molecules are transformed into ionic compounds. That is correct with prepared sodium extract. So it is correct. Statement 2 is sodium fusion extract of an organic compound having nitrogen and sulfur gives Prussian blue color. That is incorrect. If both nitrogen and sulfur is there, then Prussian blue color is not obtained. Blood red color is obtained. It means statement 1 is correct. Statement 2 is wrong. So correct answer for this question is option number 2, that is statement 1 is true, but statement 2 is false. Moving to next question. Question is which of the following happens when NH4OH is gradually added to the solution containing 1Na plus 2 and 1Mb plus 3 ions. Ksp is given. So we know if Ksp is equal to Kip, then we'll have a saturated solution, and if Kip exceeds the value of Ksp, then in that case there will be formation of precipitate. So we can consider that this is the limiting condition, and after this there will be formation of precipitate. So if we consider AOH whole twice, it will dissociate to give A plus 2 OH minus. So I am trying to find out the amount of OH minus which is required for formation of saturated solution of AOH whole twice. So we can write Ksp for AOH whole twice is 9 into 10 raised to the power minus 10. That is equal to concentration of A plus 2 into concentration of OH minus square. So I can write 9 into 10 raised to the power minus 10 is equal to A plus 2 concentration given is 1 into OH minus concentration square. So we'll get OH minus concentration as 3 into 10 raised to the power minus 5. Now if we do for BOH whole thrice, it will dissociate to give you B plus 3 plus 3OH minus. Again Ksp given is 27 into 10 raised to the power minus 18, that is equal to B plus 3 concentration into OH minus concentration cube. B plus 3 concentration is 1, so it is 27 into 10 raised to the power minus 18 is equal to 1 into OH minus cube. So OH minus concentration from here will be equal to 3 into 10 raised to the power minus 6. So we can see that BOH whole thrice requires less amount of OH minus for formation of saturated solution, which ultimately means that BOH whole thrice will be precipitated before AOH whole twice. So correct answer for this question is option number 1, that is BOH whole thrice will precipitate before AOH whole twice. Moving to next question. Question is, ice at minus 5 degrees centigrade is heated to become vapor with temperature of 110 degrees centigrade at atmospheric pressure. The entropy change associated with this process can be obtained from. So we can write like this: ice is present at minus 5 degrees centigrade. So first we'll increase the temperature of ice and we'll make it at 0 degrees centigrade. Then ice and water, liquid water, will be in equilibrium at 0 degrees centigrade. So there is change of phase. After that, we'll increase the temperature of water to 100 degrees centigrade. Then again equilibrium between water and vapor at 100 degrees centigrade, and then we'll increase the temperature of vapor to 110 degree centigrade. So we have to check what is the total entropy change in this process. So first we know that delta S is equal to Q upon T. So we have to find what is Q in these processes. So Q for this process will be CPm dt integration. Temperature will be minus 5, which is 268 to 273 Kelvin. So delta S for this process will be integration of CPm dt by temperature. Limit will be 268 to 273. For this process, there is melting, so we can write delta Hm fusion, that is heat, divided by the temperature, that is 273 Kelvin, which is fusion temperature. So this will be the change in entropy for second part. Plus water's temperature is increasing from 0 to 100 degrees centigrade. So for this process we can write CPm dt upon T. Now temperature will be 273 to 373. So this is the limit. Then water and vapor, they are in equilibrium at 100 degrees centigrade. So we can write for this delta Hm vaporization divided by the temperature. This is boiling point, so TB. Plus again there is increase in temperature of water vapor. So again we'll write integration CPm dt upon T. Now limit will be 373 to 383 Kelvin. So this expression will give us the total entropy change associated with this process. So correct answer for this question will be option number 1. Moving to next question. The correct set of ions with same color from the following is. So we can see V plus 2, Cr plus 3 and Mn plus 3. All of them are having violet color. So all three are having same color. So correct answer for this question is option 1. We can also see that titanium plus 4 is colorless, scandium plus 3 is colorless, and Zn plus 2 is also colorless ion. Okay. Moving to next question. The incorrect statement among the following is. First statement says SO2 can act as an oxidizing agent but not as a reducing agent. So this statement itself is correct. SO2 in the sulfur oxidation state in SO2 is +4, and we know that maximum oxidation state for sulfur is +6. So sulfur can get oxidized and it can behave as a reducing agent. So that statement is incorrect. If you see other statements, NO2 can dimerize easily. Yes, that is correct. It will be converted to N2O4. Third statement says PF3 exists but NF5 does not. That is also correct because nitrogen does not have any vacant d orbital, so it cannot expand its valency. And last statement says pH3 shows lower proton affinity than NH3. That is also correct. We know that as we move down the group, the basic nature will decrease. So pH3 will show lower proton affinity than NH3. So correct answer for this question is option 1. Moving to next question. The correct stability order of the following species molecule is. So we have three molecules given, P, Q and R. So we can see molecule P is anti-aromatic molecule. Molecule Q, we can see it is aromatic molecule, and molecule R is non-aromatic molecule. And we know order of stability that aromatic molecules are more stable than non-aromatic, and non-aromatic is more stable than anti-aromatic. So correct answer for this question is option 4, that is Q more than R more than P. Question is, heat treatment of muscular pain involves radiation of wavelength of about 900 nanometer. Which spectral line of hydrogen atom is suitable for this? So we can use this formula, 1 upon lambda is equal to R into Z square, 1 upon N1 square minus 1 upon N2 square. Now, I'm assuming that the line is coming from infinite orbit. So N2 in this case will be infinite. So if you substitute, it will be 1 upon 900 into 10 raised to the power minus 7 centimeter. That is equal to 10 raised to the power 5 into Z will be 1. It is 1 upon N1 square. So if you simplify this, we'll get 1 upon 9 into 10 raised to the power 5 is equal to 10 raised to the power 5 into 1 upon N square or N1 square. 10 power 5 is cancelled out. It means we'll get N1 is equal to 3. It means line is going from infinite orbit to orbit number 3. So correct answer for this question is option number 3, that it will belong to Paschen series and the transition is from infinity to 3. Moving to next question. Question is match the list 1 with list 2 and they have given name reaction and product obtainable. So first one is Schwartz reaction. In case of Schwartz reaction, alkyl iodide is converted to alkyl fluoride. So I'll write over here. Schwartz reaction, it is Ri in presence of Kf and DMF. So it will be converted to Rf. So A will be fourth one. If you see Sandmeier's reaction, Sandmeier's reaction is reaction of benzene diazonium ion. So benzene diazonium ion. So we can write benzene diazonium ion N2 plus. If it is treated with CuCN and HCN, so it will be converted to cyanobenzene. So B will be 3. So A is 4, B is 3. If you see Woods-Fittig reaction, so Woods-Fittig is Rx plus PHX in presence of sodium and dry ether. So it will give PHR. So alkyl benzene will be formed. So ethyl benzene will be for C. So C is 1 and D is Finkelstein reaction. Finkelstein reaction is alkyl fluoride Rf in presence of Ki and acetone will give Ri. So alkyl iodide will be formed. So for fourth one it is 2. So correct answer is A is 4, B is 3, C is 1, D is 2. So option number 1. Moving to next question. Which among the following react with Hinsberg's reagent? So primary amine and secondary amine will react with Hinsberg reagent. Tertiary amine will not react. So B is tertiary amine, so it will not react. D is tertiary amine, so will not react. So A, C and E will react. So correct answer will be option 4, that is A, C and E. Moving to next question. They have given a reaction and E naught value is given. In the above diagram, the standard electrode potentials are given in volts. The value of E naught FeO4 2 negative to Fe plus 2. So we can write over here FeO4 2 negative is becoming Fe plus 3. E naught is equal to 2 volt. So we can write delta G naught for this reaction as it is in plus 6 oxidation state, it is in plus 3 oxidation state. So we know delta G naught is minus NF E naught. So it will be equal to minus of 3F into 2. Second reaction is Fe plus 3 is becoming Fe plus 2. E naught for this reaction is given as 0.8 volt. So delta G naught for this will be equal to minus 1 F into 0.8. And they're asking for FeO4 2 negative to Fe plus 2. So we can write FeO4 2 negative is becoming Fe plus 2. This is in plus 6 oxidation state. This is in plus 2. E naught given, E naught we have to find. So let's say it is X. Delta G naught will be equal to minus of 4 F into X. Now let's say it is equation 1, this is equation 2 and this is equation 3. So we can see that equation 1 plus equation 2 will give equation 3. So we'll write minus 3F into 2 plus minus 1 F into 0.8, that will be equal to minus 4F into X. So negative, negative, negative is cancelled out. F is cancelled out. So we'll get 6 plus 0.8, that is equal to 4X. So X will be equal to 6.8 divided by 4, which is equal to 1.7 volt. So correct answer for this question is option 4, that is 1.7 volt. Moving to next question. The complex that shows facial meridional isomerism is. So we know that MA3B3 type complex, MA3B3 type complex will show facial meridional isomerism where A and B are monodentate ligands. So this is facial form of the molecule and this one is meridional form of the molecule. So Ma3B3 type complex is option 1. So that's why correct answer for this question is option 1. Moving to next question. CrCl3.xNH3 can exist as a complex. 0.1 molar aqueous solution of this complex shows a depression in freezing point of 0.558 degrees centigrade. Assuming 100% ionization of this complex and coordination number of chromium is 6, the complex will be. Okay, so they are saying coordination number is 3. Coordination number is 6. So we can see coordination number is 6, oxidation state is 3. So complex will be Cr. We have to make complex from CrCl3 dot XNH3. Now we know delta Tf is equal to I into Kf into M. Delta Tf given is 0.558, that will be equal to I into Kf is 1.86 into M is 0.1. So if you simplify this, we'll get I will be equal to 3. I is 3 means 3 particles will be formed after complete ionization, and we can see 3 particles are getting formed in option number 2. So correct answer for this question is option number 2. Okay, moving to next question. Again, 2 lists are given, we have to match them. First list consists of classification of molecule based on octet rule. List 2 is example. So molecules obeying octet rule. So we can see CCl4 and CO2, they obey octet rule. So A will be 4. B is molecules with incomplete octet. So we can see BCl3 and AlCl3, they are having incomplete octet. So B will be 2. C is molecules with incomplete octet with odd electron. So incomplete octet with odd electron is first one, NO and NO2. And D is molecule with expanded octet. So expanded octet we can see in case of H2SO4 and PCl5. So A is 4, B is 2, C is 1, D is 3. So correct answer for this question is option number 1. Moving to next question. Question is, for the thermal decomposition of N2O5 at constant volume, the following table can be formed for the reaction mentioned below. 2N2O5 gives 2N2O4 plus O2. Okay, so reaction given is 2N2O5 will give 2N2O4 plus O2 at T is equal to 0. Total pressure is 0.6 atm. So total pressure will be because of N2O5 itself. N2O4 and O2 will not exert any pressure initially. At 100 second, what will happen? Some amount of N2O5 will be converted to N2O4 and O2. So let's say X is the decrease, or let's say Y is the decrease in the pressure of N2O5. So Y will be increase in the pressure of N2O4 and Y by 2 will be increase in the pressure of O2. So total pressure they are saying it is X. So total pressure over here, which is X, will be equal to 0.6 plus Y by 2. They are saying X is equal to, we have to find X, and it's given that rate constant of the reaction is 4.606 into 10 raised to the power minus 2 second inverse. Second inverse means it is following first order kinetics. It is following first order kinetics. So we can write for first order kinetics log of A naught upon A naught minus X, or we can write A naught upon AT, where A naught is initial concentration, AT is concentration of after time t, that is equal to KT upon 2.303. In place of concentration, we can also use pressure. So in terms of pressure, this equation will become log of 0.6 upon 0.6 minus y, that is equal to K into T upon 2.303. See, now in this case, if this given rate constant is effective K for this reaction, then we'll get log of 0.6 upon 0.6 minus y, that is equal to 4.606 into 10 raised to the power minus 2 into time is 100 divided by 2.303. So this is cancelled out. This will become 2. So we'll get 0.6 upon 0.6 minus y, that is equal to 10 raised to the power 2, which is 100. So we'll get 0.6 is equal to 0.6 minus y times 100. So we'll get 0.6 is equal to 60 minus 100y. So on simplifying, we'll get 100y is equal to 59.4. So y will be equal to 59.4 divided by 100. So this is our total pressure. So X they are asking, so X will be equal to 0.6 plus 0.594 divided by 2. So it is 0.6 plus 0.297. So 0.6 plus 0.297 will be 0.897. So which is equal to 897 into 10 raised to the power minus 3. So X in this case will be equal to 897. But if we consider this 4.606 as only K, not the effective K, then we have to use 2 times of 4.606 in that case. So as they have not mentioned anything, I am taking it as effective K for this reaction. Moving to next question, they are saying the standard enthalpy and standard entropy of decomposition of N2O4 to NO2 are 55 kJ per mole and 175 Joule per Kelvin per mole at respectively. What is the standard free energy change for this reaction at 25 degrees centigrade in Joule per mole? So we know delta G is equal to delta G naught is equal to delta H naught minus T delta S naught. Delta H naught given is 55 kilojoule per mole, so I can write it as 55,000 joule per mole minus temperature given is 298 Kelvin into delta S naught is given as 175. Simplify, will get it as 2850. So answer for this question is 2850 joule per mole. Moving to next question. During sulfur estimation, 160 mg of an organic compound gives 466 mg of barium sulfate. The percentage of sulfur in the given compound is. So we know they have given barium sulfate weight is equal to 466 into 10 raised to the power minus 3 gram. So we can calculate moles of barium sulfate. So moles of barium sulfate will be 466 into 10 raised to the power minus 3 upon 233. which means 2 into 10 raised to the power minus 3 moles of barium sulfate is present. And we can see that 1 mole of barium sulfate will have 1 mole of sulfur. So we can write moles of sulfur in barium sulfate is 2 into 10 raised to the power minus 3. And same moles of sulfur is present in the organic compound. So we can calculate the weight of sulfur. So weight of sulfur will be moles into its molar mass, which is 32. So it is equal to 64 into 10 raised to the power minus 3. So percentage of sulfur, if they're asking, it will be 64 into 10 raised to the power minus 3 upon 160 into 10 raised to the power minus 3 into 100. So this is cancelled out. This is cancelled out. 16 into 4 is 64. So we'll get 40% as the answer. So 40% of sulfur is present in the given compound. Moving to next question. Consider the following sequence of reactions to produce major product A. Molar mass of product A is in gram per mole. So let's write the reaction. We have CH3 and NO2 at meta position. Br2Fe will do bromination in the ring. So CH3 NO2, we can write Br over here. Then SnHCl, it is reducing agent. So it will reduce NO2 to NH2. So this will be formed. After this, NaNO2 HCl 273 Kelvin, that is used for diazotization, there will be formation of diazonium ion. So CH3 Br and N2 plus will be formed, and then it is treated with H3PO2. So when it is treated with H3PO2, it will be converted to this molecule CH3 and Br. So question is, what is the molar mass of this compound? So we can see we have C7, H will be 1, 2, 3, 4 plus 3, 7 and Br. So molar mass will be 12 into 7, 84 plus 7 plus bromine is 80. So 84 plus 7 is 91 plus 80. So it will be 1, 8 plus 9 is 17. So 171 will be the correct answer for this question. Moving to next question. Question is, if 1 millimolar solution of ethylamine produces pH is equal to 9, then the ionization constant of ethylamine is 10 to the power minus x. The value of x is. So let's say ethylamine they are saying, so we have C2H5 NH2. In presence of water, it will give C2H5 NH3 positive plus OH minus. So let's say initially this concentration is C. So at equilibrium, this will be C times 1 minus alpha. This is C alpha, this is C alpha. They are saying degree of ionization can be neglected with respect to unity, which means 1 minus alpha is approximately equal to 1. Now they are saying pH is equal to 5. So at room temperature, pOH will be equal to, pH they have given as 9. pH is given as 9. So pOH will be equal to 5. If pOH is 5, it means OH minus concentration is 10 to the power minus 5, which means C alpha is nothing but 10 to the power minus 5. So concentration of this will also be 10 raised to the power minus 5, and concentration of ethylamine, which is C, will be equal to 10 raised to the power minus 3. So if you write Kb, Kb will be equal to concentration of C2H5 NH3 positive into concentration of OH negative upon concentration of C2H5 NH2. So if we simplify this, we'll get 10 raised to the power minus 5 into 10 raised to the power minus 5 upon 10 raised to the power minus 3. So this will become equal to 10 to the power minus 7. So we can write x will be equal to 7. So we have completed all the 25 questions of JEE Main session 1 of 23rd January. Thank you.